All right, good afternoon, everyone. So welcome to DesignSafe webinar in March. Today we're going to be talking a little bit about the ADCIRC suites. Clint Dawson, who's one of the PIs on the project, as well as Mahyar, Sharifi. They're both going to be giving us a little heads up on what the ADCIRC suite of storm surge simulators looks like and how you can interact with it using DesignSafe. Before we get into that, I'm going to give you guys a little bit of an intro to DesignSafe and then also a little bit of introduction to TACC and how you can allocate time on our supercomputers. So a little bit about DesignSafe. So my name is Charlie Day. I'm Director in Training and Professional Development here at TACC. I'm also the DesignSafe Training Lead. My email's on the slide. Feel free to email me if you have any questions regarding this webinar or any upcoming webinars, or any questions regarding DesignSafe, and I'll answer what I can. So a little bit about where DesignSafe came from and where it is right now. So DesignSafe came as a vision to integrate and become a dynamic part of your research workflow. What we want to do is build a set of cloud-based tools that can support and then analyze and visualize all the different types of data that you guys in the span of your work, in the span of your research. The idea is you create these big amounts of data sets, these giant data sets, big data. And the idea is, can we store that on the cloud? Can we give you the proper tools and the proper support for you to help you guys do your research work? And we want to support the end-to-end research cycle, everything from conception to publication. And not just publishing papers and publishing articles, but also publishing your data sets and making those data sets available to the rest of the community and to the public at large. And also track who's been using your data set for their own research. So the entire idea of DesignSafe is really to enhance, amplify, and link all the different capabilities of all the NHERI components. So the way DesignSafe is kind of built, DesignSafe has what we call the data depot. That's where all the data lives. And then we also have the discovery workspace. That's where all the tools and applications are available. The idea is then when you do your analysis, you save those to the data depot. You can then analyze the data depot to do your simulation research, to do your experimental research, to do the rapid research, and then take that data, take the curated data that you have, and then you can publish it, and you can create a DOI, and then from that DOI, your work can be cited. By the way, I should manage. If anybody has any questions, Zoom actually has a chat feature. If you click on the chat, you can then ask a question. We have plenty of people here at TACC who are on the call who are going to be able to answer your questions for you. That kind of gives the presenters the time to kind of move along with their presentation and then also have your questions asked as the presentation goes on. So one thing that we've realized, and at least I've come to realize in my time here at TACC, is that the most expensive, the most impactful component that we have at TACC is your data, all right? We can shut our machines down, we can restart simulations, but the data has to stay. The data has to remain. That is what's most vital to research. So for that, we've created this, what we call the DesignSafe data creation philosophy. Behind it is we wanted your data to have a flexible model, i.e. we didn't want you to be able to take your data and then put that, essentially pigeonhole that into an area that we tell you this is what your data has to look like. We want the data model to be flexible. We want it to be adaptable to what your research requires. So we have this new interactive curation process. This process allows your researchers to decide how to represent their data, what best way to represent their data, consider what is needed for the data to be understandable by an outside user. So when you do your own research work, you have a specific way of doing things, and so everything makes sense to you. That may not be the case for external users who are looking at your data for the very first time. So we have people here at TACC who help you develop a model that's understandable by an outside user. So our data curator is Marie Esteva. She is on DesignSafe, and she is a fantastic woman to work with. She will help you and help you guide the data creation process, be able to create what data model best works for you, and how to configure the model, how to configure sensor information, how to post events, how to do your analysis, and how to make a report out of all that. Maria actually does do office hours, so there's her office hours on schedule. She does these Zoom meetings. You can jump onto that Zoom meeting and ask her questions, and she'll be more than happy to guide you through the data creation process so to get your data ready to be published. All right, now a little bit about TACC. So TACC has been around for almost, I would say, about 18 years now. We have about 160 people on staff, 70 PhDs, and about 20 students as well. We are funded primarily through the NSF and through the UT system, that's the University of Texas Systems. We have about 10,000 users, over 10,000 users on over, by the time when this slide came up, it was 2,300 active projects. We have about 3,000 active projects now. I think actually close to 4 now that I'm thinking of it. And we're partnered with a bunch of different people to try and get, to build a cyber infrastructure that is capable of growing and capable of handling an exponential amount of users. And we're growing at a very, very strong rate. A couple things that are available to you guys, just at a glance. So we have 1 billion compute hours per year. We have essentially 5 billion files and 50 petabytes of data sitting in our data center. We have hundreds and hundreds of public data sets. Some of these data sets are really exciting. One of the data sets that we have is the University of Alaska in Anchorage has been monitoring and saving whale songs. And so the whale songs are actually sitting on our data set. You can go there and you can look at them and listen to them. What we are is we are a HPC center. So we have high performance computing, high performance computers, supercomputers. And we manage those systems and we make those systems available for scientists such as yourself to use. You being part of DesignSafe, you're actually, you do have access to TACC's resources. You have access to our consultants here at TACC. You have access to our web services that we have. You have access to our software stacks that we write and the software stacks that we've built, and access to our consultants. These are our systems. We have about 15 to 20 different HPC systems. Each one of those are positioned for a different type of research. They all have a specialization. Our big machine right now is Stampede 2. Stampede 2 has about 4,200 Intel Knights Landing nodes, as well as another 1,700 or so Intel Skylake nodes. The Skylake nodes have about 48 cores each. The Intel Knights Landings have 68 cores each. And what we can help you do is we can help you write parallel apps, parallel code to run on these kind of machines. Stampede 2 is actually available to you. You automatically, being a DesignSafe user, you automatically have a base allocation of about 8,000 service units and about 50 gigabytes of storage. That's roughly the use of a single processor core for an entire year. That's their base allocation. We also have other allocations that we can provide to you. So who's eligible to request additional resources? Well, here's a little list of what you need to be or who you need to be a project PI, like an NSF graduate student, research fellow, research staff at one of the federal agencies. You can be associated with a K through 12 school. You can be involved with the museums or libraries or other research laboratories, or belong to a commercial organization with strong capabilities in scientific and engineering research. So you are charged using service units. All right, that's essentially how much one node is going to be used per hour. Compute time is then charged through that using the web interfaces or Jupyter notebooks, and then storage is allocated, per 4 gigabyte year. Costs aren't very expensive. I think I do have a slide in here explaining some of the costs. But if you would like an allocation or you would like to kickstart your base allocation, fill out a help ticket or go ahead and send us an email, and then we will get the process started so you can start using our supercomputers outside of the DesignSafe environment. All right, so the different types of allocations, we have base allocations, there's startup allocations. A startup allocation could be 50,000 SUs with a terabyte of storage. A research allocation could be up to like 2 million SUs and 100 terabytes of storage. And then we also have educational allocations. So if you are looking to use DesignSafe in your class or DesignSafe for some sort of training event, you can get in touch with us and we'll see if we can put an education allocation together for you. You know, essentially, we do like 150,000 SUs, which is approximately enough for a 40-hour work week for about 50 students or so. So it's actually very, very handy to have. I do those quite a bit, honestly, for the courses we teach here. And these are what the costs look like. Storage is available for about $100 for a terabyte per year. Compute time is approximately, you know, 0.0125 cents per core hour. Feel free to go and get in touch with us, but here's what the review criteria looks like. We're looking at scientific merit. We're looking at the methodology used for the DesignSafe resource that you're needing to use. We're looking for what kind of funding you've had, what kind of projects you've done in the past. But this is all. I mean, if you have any questions, feel free to email us. We'll be happy to answer what these questions look like, and we're happy to help you put together an allocation proposal. Okay, so that was my introduction on what TACC is, how DesignSafe works, and how DesignSafe gets together. I'm now going to hand this over to Clint Dawson. He's a professor and Department Associate Chair with the Department of Aerospace and Engineering Mechanics here. So it looks like I have a misspelling on my slide. I'm so sorry about that. So today's webinar, we're going to try and discuss how to execute parallel ADCIRC jobs and storm surge models inside the DesignSafe workshops. There'll also be a little bit of a demonstration on how to create the directory, what the input files need to look like, how you submit jobs, and the entire format of it. So with that, Clint, I'm going to go ahead and mute my mic and stop my share and hand it off to you to take things over.
Okay, thank you. Can everybody hear me?
Yes, we can.
Okay.
Yes, we can.
Let's see. Yes. Okay, let me get out of full screen here. Let's see. Just one second, let me get out of full screen so I can. Okay. All right, so I'm going to be talking about, as Charlie said, the ADCIRC suite of simulators. Okay, so first of all, let me give you a little bit of history of ADCIRC. For those of you who may not know all about it, ADCIRC stands for Advanced Circulation Model. It was developed starting in the early 1990s. The development was led by a couple of professors, Rick Ludick, who's at the University of North Carolina at Chapel Hill, and Johannes Westerink, who is at the University of Notre Dame. And since that time, it's the number of users and number of developers has grown quite a bit. And now the development is led by a bunch of people who we collectively call ourselves the ADCIRC Users Group. And we have a meeting once a year, and we also share code. We have a GitHub page where you can also download the source code and see all of the revisions that have been made to the code. What ADCIRC does is it simulates free surface circulation and transport in coastal environments. It solves the depth average shallow water equations. So that means that two-dimensional shallow water equations essentially on the sphere. It's used for a number of applications, for different applications, but within DesignSafe, it's commonly used for storm surge modeling.
Hey, I'm sorry, Clint. Do you have slides that you're presenting?
Oh, yeah.
Or
Okay.
Yeah, if you go to share and then select which window you want to share, it should appear.
Okay. Now can you see them?
Ah, perfect. Thank you.
Sorry. I guess I didn't do the share correctly. Thank you. Okay. Yeah, so what I just said. It was developed in the early 90s. It simulates free surface circulation and transport, solves the depth average shallow water equations. Within DesignSafe, it's commonly used for hurricane and storm surge modeling, which is probably what most of you are perhaps interested in using it for. It's a finite element based code, which typically means that you use unstructured meshes. And in our case, we use unstructured triangular meshes, which are highly unstructured. In other words, they go from very large in the deep ocean to very small in the coastal environments. So a typical application of ADCIRC requires several large input files, and hopefully most of you have had some training or have gotten hold of some of these input files or know how to generate them. But they're usually generated with a piece of software called SMS, which is Surface Water Modeling System. And this is a commercial piece of software. There is a fairly inexpensive license for universities, but if you want to know more about SMS, you can ask me later. So PADCIRC, which is what we primarily run through DesignSafe, is parallel ADCIRC. So it runs on multi-core computers at TACC. Now, we also have ADCIRC plus SWAN. So this is another code which not only simulates the free surface circulation and transport, but also computes spectrally averaged short waves. And so it's actually a combination of a code of ADCIRC and a code called SWAN, which was developed. SWAN stands for Simulating Waves Near Shore, and it was developed at TU Delft. And SWAN solves what's called the wave action balance equation. So if you're interested in storm surge modeling where waves are an important component of the physics, then you probably want to use ADCIRC plus SWAN. Now, fortunately, SWAN runs on the same mesh as ADCIRC, so you don't have to really change your input files very much. There's a couple of additional control files that are needed to run SWAN, which I'll point out when we get to the directories. So PADCSWAN is the parallel ADCIRC plus SWAN, or maybe I think in DesignSafe it's called PADCIRC-SWAN. So there's really good documentation for the code. It's available at this website, www.adcirc.org. If you're interested in hands-on training, there's an ADCIRC boot camp every year, usually in the spring. And the person who runs that boot camp is Jason Fleming, and this is his email address. Now, there are different versions of ADCIRC that are released every year to 2 years. And as stable versions are released, we'll continue to update them in DesignSafe. But the versions that we're running now are based on version 52 of ADCIRC. And I think the latest release version may be version 53 or even later. But version 52 I know is a stable code, and so we're sticking with that for the time being. If there are other versions of ADCIRC that you need to run, then let us know, and we might be able to make them available through DesignSafe. Okay, now the next few slides are screenshots from the DesignSafe web portal, and so I'm going to switch over now to the web portal and try to just do a hands-on demonstration if I can. So, can everyone hopefully still see my screen?
Looks like something might have froze. If you want to stop sharing and reshare, that probably would work.
Okay. Can you see this screen now? Okay.
That's perfect.
All right. All right, so here we are within DesignSafe. We're in the main landing page when you log in. And so we go, if you want to run ADCIRC, you go to the Research Workbench and click on Workspace, which I'm already in the workspace here. And then we click on Simulation. And here's ADCIRC as the first application. So if we click on ADCIRC, we'll see a little bit of a introduction. And then we have a drop-down menu. And you'll notice that there's actually 6 versions here. ADCIRC version 51, ADCIRC version 52. Those are serial versions of ADCIRC. This would be just for running small jobs, say on a single core, just for testing purposes. But the large parallel codes are the PADCIRC for Lone Star, PADCIRC for Stampede, and PADCIRC-SWAN for Lone Star, and PADCIRC-SWAN for Stampede. I don't think it matters so much which machine you use here. The input files and so forth are the same. Nothing changes from your end. It's just a question of which TACC resource is running faster and also not under maintenance that day. So let's say that I choose PADCIRC Lone Star 5. Then you get this screen here. Okay, so the first thing you want to do is to select your input directory. I should also mention that ADCIRC will allow for netcdf output. So we have it compiled to run with netcdf output. So if you have that, if you want to use that option, you can. All right, so now it's asking me to select my input file. So let's say that I want to run this particular hurricane, Storm 36. So I select that input file. Now we have to type the mesh file. This is our, what we call the 4.14. We have to type the maximum runtime. This is the number of hours that you estimate the job will take to run. So let's say we're going to estimate that it's going to take 10 hours. We need to give it a job name. Say test Storm 36. We can give it an output archive location if we wish to. Usually I just skip that. And now you'll see a drop-down menu for the node count. Now, on a node on Lone Star is 24 cores. So one node is 24 processors. We can choose up to 12 nodes, which would be 12 times 24, or 288 cores. That's the maximum number of cores that we can get on Lone Star. On Stampede, I think there are more cores per node, but I'm not sure that we're using more than 24 cores per node on Stampede. So right now, we kind of have it limited in the number of cores that you can use. If you need more cores, then you'll need to get a special allocation for that. Okay, so once I have all this typed in, I click Run. And it submits the job, and hopefully this will work. Okay. So now you see on the job status, test Storm 36 pending. Okay, so it takes a while for it to queue and then start running. It may take a few minutes or even a little longer for it to queue up. But you can check your job status here in this panel over here. All right, so that's how you would execute a job. Now let's say, let me go back to my input files. So let me go to the data depot, go to my data. So the input file, the input directory that we just used is this Storm 36 netcdf. And here are my input files. So if you're familiar with ADCIRC, you're familiar with these files. So I have my 4.13, my nodal attributes file, 4.14, my mesh, 4.15, my control and parameters file, 4.22, 4.221, 4.222. These are my WIN inputs. So these are the sort of the files that you need to run PADCIRC. Let me go back to my data. Now, if we're going to run PADCIRC plus SWAN, then we have the same files as before, but we need to add this 4.26 file, which is a SWAN specific file, and this SWAN init file, which is another SWAN file. And this particular application, we were writing some SWAN output at some particular stations, so I have a stations file as well, but this is not mandatory. All of these other files are mandatory files to be able to run. So hopefully you all have had some training on how to generate those files or already have access to those files. But if you don't, then I would suggest going to the ADCIRC bootcamp. Okay, and another thing I wanted to point out is once your job has run, go back, you want to see where your output is. You go into Archive, you go into Jobs. You'll see the dates of all the jobs that you've run. And you'll see that there's a directory already created for the job that I just submitted, although there won't be anything in it. This is a job that I ran yesterday. This is for the same storm. So here's some, if you have an error, it's usually in one of these, in this error file. But hopefully we have our output in this directory here. Yeah, and there it is. So all of our output, these 4.61, 62, all of these are output files that you can now download and process as you wish. Okay? Yeah, so they're all there. Okay, so let me go back to can you see my PowerPoint again or not?
It seems like Zoom's having issues when Windows, maybe trying to minimize a window. It froze right in the middle of minimizing it.
All right, let me do this, share my screen again. Like we have some questions. Yeah, the slides will be made public. Okay. Okay, can you see my PowerPoint slides now?
Yeah, we're good. Thank you, Clint.
Do this again. Sorry, I'm having to move Zoom stuff around. It's like all right. So I just went through several of these slides. These are just screenshots, as I said. This is the workspace page. This is your how to submit a job, how to submit a SWAN job, what your input directories should look like, where your output is, what your output files should look like, where they're located. Now I'm going to turn it over to Mahyar, who's going to talk about, once we have these output files, what can we do with them within DesignSafe. So let me stop sharing and turn it over to Mahyar.
Okay. Thank you very much, Clint. Let me share my screen now. So So hopefully you guys can see the screen, and Charlie, let me know if there is any problem with the screen. Essentially, I will be discussing some of the geospatial capabilities of DesignSafe in the context of a practical problem that is related to storm surge modeling. Here we are going to introduce a workflow that can benefit from DesignSafe cyber infrastructures. Here the objective is to locate the addresses, let's say, that will be inundated on Galveston Island in the state of Texas, for example, as a result of one of the storm surge models that will be running for an impending hurricane. As shown by Clint, maximum water levels, for example, are one of the outputs of the ADCIRC in the format of NetCDF, which essentially can be converted into a format that GIS will be able to read, and further users will be able to integrate that with other special data sets, including like elevation and property data to solve such problems. Finally, with those, we can identify the addresses of the buildings that will be inundated, for example, by the simulated water levels. So here is the workflow that I will be kind of like showing here. We will be using the Kalpana software to convert the NetCDF outputs of ADCIRC, which in this case is the maximum water levels, into GIS shape files. And we'll integrate that with the data sets and perform some special processing to kind of like come up with the output map, as well as to find and locate the inundated areas. So here, I will also start kind of like going through on submitting how users can actually submit a job to Kalpana software through the DesignSafe Workspace. So Kalpana software can be found under Visualization tab, and here you will have a little bit of information on what Kalpana is, which is actually a Python script that can convert ADCIRC outputs to GIS shape files, and similar as what you have seen for the ADCIRC, you will have this type of form that needs to be filled with relevant information to make the conversion. So in this case, the working directory could be a folder that contains your files, and in this case, I will be converting a maximum elevation NetCDF file, which is output of the one of the simulations. Next, you will be able to select one of the two options of whether you're converting the maximum elevation, maximum water levels, or maximum window speeds. And you will be able to select the vector shape, which could be either of polyline or polygon. And you can also select the contour type in the formats of contour range, which accepts a minimum, maximum, and interval, or actual sets of contour levels, which will accept a custom set of contour levels with whichever spacing you would like. So here you can kind of like provide some sort of contour information here. This shouldn't be a very big job, so it will only kind of like I will select a maximum job runtime of like 20 minutes here, and give a recognizable job name. So for regarding this archive location, usually it would be better to kind of like to let it go as it's gonna feel by default, and that will be similar as to the ADCIRC outputs. It will be going to archive jobs in a directory created at the date of the job submitted under a directory name which has a job name dash the job ID. So once you have that, you can kind of like start submitting the job, and you can follow the status of the job to the right after the job being submitted. So it will kind of like change from pending to submitted and running, and essentially hopefully finished. And once that is done, similarly, you will be able to go back to Data Depot, and you should be able to find the results of your the outputs in the archive under jobs. And here. So this is the job that we just submitted. It might take a while before it finishes. So I have tested this before, and here is the outputs of Kalpana software. It will be under this directory. You will be having your inputs as well as an output directory, which will contain water level shape files. So later, you will also be able to kind of like go back to Workspace and perform your geospatial processing using a QGIS, which is an open source software that can perform spatial processing to create output maps. It can be used to create, edit, visualize, and analyze geospatial informations, and you can find it in the DesignSafe Workspace under visualization and here in the QGIS desktop. This form is much easier to fill. It's actually going to create an interactive QGIS desktop session which runs on a virtual machine, and you would only need to select your desktop resolution and give it a name to launch. Keep in mind that once the job is submitted, it may take like a few minutes before the session, the interactive session is ready for you. And once that is ready, a window will pop up which gives you some information with a connect button that will allow you to connect to the interactive QGIS desktop. So as you can see, after pending, the job status will change to staged, and as I said, it may take a while. So also remember that you will be able to move around the files in your data depot to kind of like from the archived location to a working directory, or even to your My Projects, where you would be able to share it with other colleagues. So as you can see, the interactive session is ready now, and we can connect to it, which brings us to our virtual machine session. So depending on how familiar you are with the QGIS, I will essentially not go through details of this, but just to show you how to actually visualize such outputs. So you will be able to access to the My Data and My Projects that are mounted here from the from your DesignSafe account. You will also have access to all of the contents, including the archive file and the outputs of the. Let's say you have run its ADCIRC simulation. And you have that file outputted, and you have maybe moved that into some sort of a folder in your My Data. And in this case, I have this under this folder. So you would be able to go through here and for the Kalpana output shapefile that we had, you can kind of like bring here and visualize the contour levels of polygons that are drawn here. So also furthermore, you would be able to kind of like perform some of your analysis, and for that I will start by opening this project that I have created before. Here you would be here we have the locations of the buildings that are in the Galveston, Texas, Galveston Island in Texas, and we have access to the digital elevation model, as well as the water levels from two hurricanes, Hurricane Ike and Storm 36. And we have compared to see where are the locations of the houses that will be inundated. These particular ones are for Hurricane Ike, whereas for the Storm 36, you will see that particularly in this region, the water levels were much higher, and showing that many of the houses are inundated. The process that we have completed this was through the point sampling tool, as well as some of the field calculations in the attribute table to kind of like assume the first floor elevation, compute the total heights, and see what would be the height above the water to kind of like compute the inundated buildings. So there are lots and tons of capabilities with the QGIS, which you could benefit from using the capabilities in DesignSafe cyber infrastructure, and further you will be able to handle and process a much heavier type of workflows using the outputs of simulations from the ADCIRC. So with that, I will go back to the slides. So here we talked about Kalpana and how to submit jobs through QGIS. You will be able to essentially visualize the shape files of different hurricanes that you will have run, and maybe even compare them and also post-process them in QGIS geospatially to compute to solve one particular research objective. And in this case, we were thinking about to see if one particular house was flooded or not, which would be essential and result into address outputs, and this would be essentially important for first responders to kind of like in emergencies related to that. With that, I will get this back to Clint to talk a little bit of more on in case the DesignSafe Workspace resources are not sufficient for you, what are your options to submit the jobs through the command line interface.
Okay, thank you. Go back. Okay, can everyone see my desktop? All right, so any problems, Charlie? Can everyone see it? Okay. So the last thing I wanted to show you is, so one of the things that we have to do, Mahyar mentioned, if you want to submit a job through the command line, we can do that as well. I also want to talk a little, just say a little bit about moving these large files. All these files, for example, this 4.14 file is 231 megabytes. This WIN file is 695 megabytes. Some of the output files are gigabytes. So those are really large files to try to move through any web interface. Now, one can use Globus. That's and there's some training on Globus in the Learning Center. Another option is to just simply use the secure copy feature through Jupyter. So let me go to data processing. So Jupyter is an application, a web application. It's got lots of features to it. You can do many different things. You can do notebooks and so forth. But one of the nice things about it is that you can open a terminal. And now it's just like we have logged into the supercomputer directly, or DesignSafe directly. So you can see here my data directory here with all my directories in it, Storm 36, etc. So let's say that I didn't have this directory created already, or I had the directory created, but I was trying to move files into it. Then I could just simply, at this point, SCP from my local machine to this directory. And so that's one way that you can move files back and forth between your local machine and DesignSafe. Another thing that Mahyar mentioned is that if you want to use the command line to run jobs, if you have an account on Lone Star 5 or on Stampede 2, then you can SSH to those machines directly. We have to use this two-factor authentication now. Okay, so I can just get directly into my Lone Star account, and I can submit jobs from here if you have a Lone Star account or if you have a Stampede account. So that's kind of the last thing that I wanted to mention. I believe that concludes the webinar. Hopefully this has been informative for you. Again, these slides will be available. I think the webinar hopefully was recorded, and you can view it later at any time. And if you have any questions, just feel free to contact one of us or submit a help ticket through DesignSafe, and we'll get back to you as soon as possible.
Let me share my screen here real quick. I have some information available if you guys do have any questions after the webinar is over that you wish to share.
So, yeah, we'll be sending Charlie our slides as soon as this is over with, and I guess they'll be posted in the Learning Center. Is that right?
Yeah, under the Learning Center on DesignSafe.
Okay.
So let me pull my screen back up. Can everybody see that all right? Should be my presentation. All right, so if you have special thanks to Clint and Mahyar. I've worked with them very closely in the past, and they are both great guys. If you have any questions at all, feel free to contact us, and we'll make sure that your questions go to the right people. I did want to give you, I'm sorry?
Did you share?
I did want to give you, oh, okay. Am I not sharing? Oh, one more time, I'm sorry. That's odd. All right, let's go back here. Okay, there we go. And share. All right, now we should be able to see that. All right. Yeah. So once again, special thanks to you, Clint and Mahyar. You guys are great. Like I said, I've worked closely with both of them, and they've been fantastic to work with. If you have any questions regarding anything we've covered today or any other general questions regarding DesignSafe, feel free to contact us. We are on Slack. If you go to DesignSafe-CI.slack.com, you should already have an account created for you, or you can go ahead and fill out a help ticket on DesignSafe, and we'll get an invitation to Slack sent out. That's probably one of the best ways to contact any of us here at TACC or any of the DesignSafe personnel or any of the other researchers in the community. You can also email us at training@designsafe-ci.org or fill out a ticket. As Clint said, in DesignSafe under the Learning Center, this presentation will be shared there as soon as the video is completed, and the slides will be available. A link to the slides will be available there as well. Once again, my name is Charlie Day. I am the training lead here for DesignSafe. If you guys have any questions, feel free to contact me, and we'll help you guys out. So with that, if you have any questions right now for Clint or Mahyar, feel free to jump on the chat and ask them. We'll leave it open for another couple minutes if there's any questions. If not, it's been fantastic to have you guys this afternoon. Please keep an eye on the DesignSafe calendar. We'll have other webinars coming up here in the near future. Thanks again. Appreciate it. Have a great afternoon, everyone.